like it. Awesome. All right, well, we'll go ahead and get started in the interest of time. So I think I know, or at least been introduced to a number of you guys. I'm Elizabeth Scutchfield. I'm the Director of Partner Relations here. We host these talks weekly in order to continue to raise your awareness about what's going on out in the industry, so you can have more informed conversations as you're getting out and going to things like meetups and scheduling your own networking coffees. So excited today to invite Nell Shamrell Harrington. And so Nell is an advocate for non-traditional talent because she herself is a non-traditional candidate and got her career started with a theater major. So she'll tell us a little bit more about that. But she has been really involved with Operation Code. For those of you who don't know about Operation Code, it is a really great meetup that is supporting veterans who are seeking to transition to tech and figuring out kind of how to navigate that pivot. So if you are a veteran or not a veteran, I encourage you to take advantage of that. When's y'all's next event? In January?
In January, I think so.
Okay, cool. So anyway, she's been a great advocate for our program, and so she's going to talk today about web operations. And take it over.
Starting off with a round of applause. I like this. Well, good afternoon, everyone. As Elizabeth said, I'm Nell Shamrell Harrington. I am a principal engineer at Chef Software and also CTO of Operation Code. Now, I'd like to start off this with a story, which is a long time ago in a galaxy not so far away, I deployed my first Ruby on Rails app to the web with one simple command, which might look familiar to some of you. Git push Heroku master. Who here has deployed things to Heroku like this? Awesome. Now this seemed like magic. It seemed like my application could just go directly from my laptop onto the internet where anyone can see it. I think I sent a link to my mom. Now Heroku does indeed make deploying applications very easy by hiding most of the deployment process under the hood. So from the developer perspective, this is magic, but there's a whole world underneath that magic. And that is the world of web operations. Now when I say web operations, I mean anything involved in an application being runnable and accessible over the internet. It's that wizard behind the curtain. It's work that as an end user you often don't see, but you definitely notice when it's not working right. And tonight we're going to do a quick, or today, whatever time of day it is, this day, we're going to do a quick intro into what web operations is and where it's going. But first, as mentioned, I'm Nell Shamrell Harrington. I'm an engineer at Chef. I'm, along with being a principal engineer, I'm the community engineering lead, which means I lead all our open source efforts. I'm also currently the Chief Technology Officer of Operation Code. We work with veterans and military families to help them transition into software engineering careers. At the end of this year, I will be moving on to the board of directors, but still very much involved with it. So back in 2009, my first developer job was at the University of Washington Department of Physics. And like most university departments, government agencies and companies, we had our own server room. Now it did not look nearly as nice as this picture. It was big racks of servers connected by tangled snakes of Ethernet cords running all of our organization's IT. I know one of our technicians once brought down the internet for the entire first floor of the building just by disconnecting the wrong Ethernet cord from the wrong server. So what this looked like is in these days it was common to run one application per server. If you were running a PHP app, you likely would be running what we call the LAMP stack on the server you wanted to run your application on. So what this means is you would install Linux on that server, and then you would install the Apache web server to take your application content and serve it over the web, followed by a MySQL database if your application required a database, and then the PHP programming language and runtime. As this is a PHP application, we need support for that language on anything we're going to run applications with. Now this worked for a while, but as the number of applications run by an organization and the cost of running those applications went up, organizations found themselves asking a new question. What if we could run more than one application on one server? You know, do I really need to buy a server per application, especially at organizations that have hundreds, if not thousands, of software applications? What if I could somehow divide that server into multiple parts, which could each run a separate application on just one machine? Well, enter virtualization. Virtualization involves running multiple virtual machines on one physical machine. Each application appears to have its own environment, even though they all share the same CPU and memory resources. So I could have one server that was running Linux as its base operating system, but then I could have a virtual server on that physical server, one that is running Linux, but also includes Apache, MySQL, and PHP, that whole LAMP stack. Moreover, I could have another virtual server running the same stack. And then the great thing about virtual machines is I could run an operating system in a virtual machine that is different from the physical host operating system. So I can have Linux virtual machines and Windows virtual machines, FreeBSD virtual machines if you're into FreeBSD, all running side by side. Now this proved to be quite popular, but companies still had to buy physical assets to run these machines, which could cost quite a bit up front. Now companies started asking, what if I could run my virtual machines on someone else's hardware and pay for it only when I need it? And that is where cloud computing comes from. Now I have a sticker here on my laptop. I haven't got asked to take it off my work laptop yet, but it says there is no cloud, just other people's computers. That pretty much is what the cloud is. It's using other people's hardware to run my virtual stuff. So companies like AWS, Microsoft Azure, DigitalOcean, Google Cloud, these are some of the most popular cloud platforms in use today. Also, every one of these, I think including DigitalOcean, but I'd have to check, have some sort of free tier. So you can start playing with it. You can start getting to know their technologies. They are very invested in every developer being able to use their technologies as much as possible because that's where they make their money. Now, these companies realize they can make a lot of money, and they do. AWS and Azure bring in massive amounts of cash by renting out parts of their physical hardware for people to use virtually. So this lets other companies not have to worry about buying hardware, and they only pay for the virtual machines and resources that they actually use. So AWS charges by the hour. So if I only need a virtual machine for a couple of hours, I'll only pay for those hours. DigitalOcean charges by the second. At least they used to. I'm pretty sure they still do. So if I need to spin up a virtual machine just to run some tests on, and it only takes 30 seconds, I'll only pay for those 30 seconds. So cloud computing makes it so that companies don't have to have fleets of physical servers waiting around just in case traffic on their website increases and they suddenly need more infrastructure to manage the load. Now, I did an on-site with Nordstrom, who is a Chef customer, a few years ago, and they told me their biggest website traffic day is actually not Black Friday. It's the semi-annual sale. If their site goes down the semi-annual sale, they are losing out on a ton of revenue, which means they need a massive bank of servers to run their software. They run their stuff in AWS, they're open about that, and that means they can expand the number of servers they have or contract them as needed. So both virtualization and cloud computing have been mainstream for a few years now. But there's another form of infrastructure that's been gaining a lot of popularity over the past couple of years. Enter containers. Who here has heard of containers? Got a few of them. So when you spin up a virtual machine, you need to put an entire operating system in it. But what if you don't need the entire operating system to run your application? What if your application or parts of your application only needs certain parts of the OS? Why would you want to burden yourself with having to have the entire OS that you'd have to keep up to date? So containers have actually been around for a while. They've been a part of Linux for a long time. But one company, Docker, brought them into the mainstream by making them straightforward and almost friendly to use. I was at, I think it was DevOps Day Chicago I was speaking at, and during another speaker's presentation, it had nothing to do with containers, but every once in a while, he just put a slide up on the screen that just said Docker. Then he would pause for a second and say, okay, I knew that would get your attention. Now let's move on. So containers use just enough of the operating system to run the application or a portion of the application, nothing more. This makes them very fast to spin up and spin down, and you can fit many more of them on one host than you could virtual machines. So how these work is we have a container host. Now this is a physical server. And I can have containers running on that physical server. I can have one container running Apache for my LAMP application. I can have another one running PHP, and I can have lots of containers running other services very easily. Now how I spin up these containers is through creating a container image. So what I do is I first take my application code, then if it's Docker, I add in a Docker file. So what the Docker file does, it's loosely YAML, is it specifies exactly what parts of the operating system and exactly what parts of the web server or whatever it is that I'm using that I need to use to run whatever service I want to run. So I explicitly tell it, put these things in the container. If I don't tell it to put it in the container, it doesn't. And from that Docker file, you use Docker software to create a container image, which you can then either keep that on your workstation or you can upload it to a central service like Docker Hub, which then means if it's on that central service, that central cloud service, I can pull that Docker container image from anywhere that has access to Docker and access to the internet and run it on that piece of hardware. So you take that container image, and on a container host, you spin up a container based on that container image. So there's two key parts of Docker to understand here. One is the container image is the pattern for the container. It's the specification of what I want in it and what I don't want in it. The container itself is that piece of virtualized computing hardware that is spun up from that container image. Now, if I want to change something in my container, one of the key things to understand is it's a bad idea to SSH into that container and manually make the change there. You can do that, but it's going to hurt. Because once you do that, my container is no longer in sync with my container image, which means it's going to be really difficult to spin up another container with those same configuration elements in it. So it's a lot better to, when you need to change your container, make the change in the container image and then spin up a new container from it. The great thing about containers is they're fast and they're frankly cheap to use, so that it's easy to spin one down, make changes to the image, then spin up another one. Now I want to give you a few guidelines. A deep dive into containers is out of scope of this talk, but there's a few things I want to make sure everyone remembers. One is that containers should be disposable and short-lived. You should very easily be able to spin them up when you need them, then kill them when you don't need them. The fact that they spin up so fast is their major advantage. And that they are disposable means no persistent data should be kept in a container. And by persistent data, I mean anything that should stick around from deploy to deploy, like the data in a database. When I began as Operation Code's CTO, someone had set up the Postgres database to run in a container. And I think they were learning containers as they were going along, which is absolutely fine. But the problem was, if that container went away, all of our data would go away. Now, a way around this is you can have an external volume where you keep all of your persistent data, like your user logins, the products people have ordered, etc., and mount that onto the container. But that data should not be kept in the container itself. Now, what if you need your containers to access persistent data from somewhere, or to access networking and more resources? Well, this can get tricky as containers come and go so frequently. So this brings us to the question, when you have lots of containers, how do you coordinate and manage them? Especially if they need to touch outside services like DNS or load balancer. Well, recently, we've seen the entrance of container orchestrators. In order to manage containers and all their resources, we often use an orchestrator. And by far the most popular container orchestrator is Kubernetes. You've probably heard this term. In fact, we just had KubeCon in Seattle this week. So Kubernetes, what it does is it lets you define what containers should be spun up, what resources they should access, and how they should interact with each other. So Kubernetes is not necessarily building or controlling the container image itself, but it helps you define how your containers should interact with each other and anything external. So with Kubernetes, I can orchestrate groups of containers. So I can have one group of Apache containers running my web server and another group of PHP containers to execute my app. And then I can manage their connections to other resources. This can include a domain name to access the cluster over the web, and also a separate database. So what we ended up doing with the Operation Code site was we migrated all the data into a Postgres database in AWS that is not in a container, but is easily accessible from the container. And we control the way it accesses that through Kubernetes. So if you're interested in Kubernetes, there's and web operations in general, there's there's two resources I usually recommend. And the first is OpSchool, which is an open source curriculum that takes someone new to web operations through the basics, intermediate concepts, and the advanced concepts. Now, if you'd like to better understand Docker and Kubernetes, the resource I most recommend is the Children's Illustrated Guide to Kubernetes. I can tweet these out afterwards, these links out if people like. The hardest thing about learning Kubernetes is the vocabulary, because it's so different than what has come before. This is a beautifully illustrated children's guide about Pippi, the PHP app, and it goes through all the different concepts, explains how they work together, explains where containers come in and such. I really recommend it. And with that, I want to say thank you, and I want to make sure to leave lots of time for questions. If you'd like to know more about my background, yes, I was a theater major. I focused on acting and sound design. I did I did some stunt work and stage combat work, which is probably what I enjoyed the most. But let's go ahead and open it up for questions. Yes, sir.
I'm interested in what you do with Chef as their principal engineer, and just kind of like how that works. You mentioned Orchestrators and working with that.
Right.
I'd like to hear a little more about that.
Sure. So the product I've worked on most recently is called Habitat. And it's a way of making it very easy to take one application and export it to container image or export it to something to run on a physical server. The idea is to make your application agnostic to running in any environment. The way I explain our core product, Chef, is Facebook is one of Chef's customers. And I'm allowed to say that because we have a website where it says customer stories. I take that, any customer on there I believe I'm allowed to talk about. So Facebook has hundreds of thousands of web servers. They serve 2 billion users. Imagine trying to update each of those by hand. Imagine a security patch comes out and you have to manually apply it to each one. That would be impossible. So what we do, what Chef, the product is, the core product, is we provide software where someone can define a template, what they want their infrastructure to look like. We call them recipes. And you can have multiple recipes in a cookbook. We really like food analogies, as you can probably tell. I get asked what restaurant I work at a lot when I wear my chef sweatshirt. But basically, you can define how you want your infrastructure to look like in one template. Then we provide software that lets you spin up new resources exactly to that template, as many as you want, and keep them all in sync. So if a security patch comes in, that needs to be applied to 10,000 servers. You just have to make the change in one place, and it will automatically propagate it out to the entire fleet. So we really focus on infrastructure at a massive scale. What I do as principal engineer, I was promoted recently from my work on Habitat to community engineering lead. Chef has 1,200, would be my estimate, open source projects right now in various stages of maintenance and such. And my job is to make the governance of those projects, governance is a big part of open source, work well together. I haven't figured out how to do it yet. That's what I'm working on right now. But as principal engineer, usually you're in kind of the higher architect-focused role, depending on the company. Yes, sir.
I have two questions. First, thank you for being here.
Sure.
First question has to do with what you said about open source. For those of us that are moving into the development world and trying to build up a resume and that kind of thing, and build up our commits and all that, how would you recommend where would we start to get involved with an open source project? What's the best way to integrate that? And then I'd love to hear more about your beginnings in tech and how that's happened.
Sure. I'd say I tell people the best place to start is take a project that you use, an open source project that you use. I have a feeling you've been exposed to a number of them here at Code Fellows. Look at the documentation for it on the GitHub repo. Write up how you used it and see where that might be missing. So what I found as an open source maintainer is often I've been staring at the code for so long and using it so long, I forget what the perspective is like for someone who's coming to use it for the first time. Adding that content into the README, just a basic walkthrough of how you use this project or how you do this part of a project, tremendously valuable. And the great thing about that is that, number one, gets you used to the GitHub flow and collaborating with people in an open source project. And that also helps the maintainers see that you might be someone they can give some coding tasks to. Often when you're looking at issues for a pull request or for an open source project you want to contribute to, the good ones have labels that mark things as good first-time user or a good first-time contributor or beginner-friendly. A lot of chefs, we make an effort to do that. Start with those. Even if it seems a little simpler than maybe what you were looking at, part of what you're doing is building trust with the maintainers of the repo as much as adding code. So I do tell people, start with documentation. Please do not start by changing the white space and only changing that. That happens a lot. You need to add something of value to the project. Documentation always adds value.
Okay, great. And your beginnings?
Oh, my beginnings. Well, how I came to Operation Code, I'm not a veteran myself, but I'm the daughter of two. Both my mother and my father were 20-year Air Force officers. And one of the nice things about growing up in the military is I think partly because of it, I was exposed to technology at a much younger age than most people were. This was late 80s, early 90s. My mom has a picture of me in diapers in front of her old K-Pro 2. It was one of those computers with the black screen and the green text. So I did always have some access to them, but when I went to all-girls Catholic high school, St. Mary's Academy in Portland, Oregon, and it's a great school, but there was not any computer science curriculum. This was in the really early 2000s. We did a little bit of programming with the TI-83 calculators. I used to put games on them, which was my favorite thing to do because it looked like I was doing work, but I was playing Tetris, or we had one for blackjack, actually, which, being in a Catholic school, that might have got us in some trouble. But anyway, so I went to college, and my first year I took the intro computer science course. I found out pretty quickly it was geared toward people who had computer science in high school, which I was not. And this was before there were a lot of free coding resources available on the web. The web was still kind of new at that point. So I got through the course, and I took one other course, but I really didn't think it was something that I liked. Now I graduated college. Bless you. I graduated college in 2007 with a degree in theater. 2008, the economy crashed. There were no theater jobs to begin with. There were really no theater jobs, particularly that would allow me to support myself after that. I have 3 younger sisters, so my parents supporting me beyond college really was not an option. So I got a job as an office assistant initially at the University of Washington Physics Department because I needed to get out of my parents' house, and it was the only job I could find that would pay enough for me to live on. Once they figured out I knew how to code, though, they started giving me more real-world coding projects because they always needed code. They always needed help with the classroom websites. Students always needed help figuring out how to do things on the university systems, which were not standardized at that point. So they figured out I could code. I discovered when I have a real-world scenario, a real-world project with a definable outcome, I really enjoy it. Partly because there's tremendous creativity in how you can execute on that project. One of my first big projects was creating a database view that would allow someone to put in various search criteria for all the grad school applicants to the physics program. We maintained, I don't think they do anymore, but at that point we maintained our own grad school admissions programs. And then get how many women applicants there were, how many applicants from outside the US. Once I got a taste of that and saw how much the other people in the office appreciated it, that really got me to the point where, all right, programming is something I want to do. I was a theater major. I have to be doing something creative. This is tremendous. I wouldn't have known it from my academic courses. This is a tremendously creative process. So from there, about a year and 2 years later, I was programming but still making office assistant salary. And at that point, this was 2009, I think, the university, the Washington State had slashed so much funding, there really wasn't an option to move me into a full-time programmer position. So I left there, got my first programming position at LexisNexis in Bellevue. That was an interesting, I have a feeling what you know what I'm talking about. I lasted there about 7 months because the corporate culture was not what I was looking for at all. But after that, I got a job at a startup as a Ruby programmer, and I've been doing Ruby programming, Rust programming, JavaScript, everything under the sun ever since. The beautiful thing about doing open source work is it's very public. which means I get to perform. I speak at a lot of conferences as a result of it. I'm someone who needs to be on stage at least a few times a year. I get disruptive. Well, disruptive is a good thing in the tech industry, but not the good kind of disruptive. So that's pretty much my background. Open source was a major factor in me getting into Chef. Because I contributed to their projects, they saw how I worked, and that made them trust to bring me in.
Great, thank you.
You bet. You have questions? Yes?
Yeah, so I have a question that initially it sounds like an impression that the container is something alternative to the cloud computing we have. Is it true, or it's more like build on each other?
Sure. I just realized I should be probably be repeating the question. So, question was, are containers an alternative to cloud computing, or are they something that builds on it? I would say there's something that builds on it. The main difference, like the technical difference between a virtual machine and a container, it's what you put in it, number one, but also two, how it interacts with the host operating system. So I tell people containers are great for anything that it's not going to be a big deal if it goes down from deploy to deploy or you lose what was in it. For something you want persistent data on, I often recommend virtual machines. Now, if you're doing Bitcoin mining, you're probably going to want a physical server with a high GPU. So which one you use depends a lot on the problem and what you're trying to do. Other questions? Yes?
When you start to look a new set of open source code, and how do you decide, like what's your process of deciding, okay, what contribution am I gonna make?
Right. The biggest one is I usually come to the project when I'm a user of it, and what is causing me pain about using it? Is there already an issue in the GitHub issue around that pain? And that is often where I go to first because I know how to verify whether it works, which is a big one. And I know what the value of that will look like. Sometimes someone will send me a message saying, hey, can you check out my cool new open source project? Is this something you want to contribute to? I take a look at it, I use it, and based on my usage of it, I decide whether I want to contribute to it or not. I look at what's missing. Now, if you're newer in open source, again, I recommend looking at documentation or issues that are labeled good first-time user. Don't make your first open source project the Linux kernel. Just don't, for a variety of reasons. If you see something and they have issues and some of them are labeled as good first-time issue or something to that effect, that shows that the maintainers have at least thought through bringing people who are newer into the project and will probably be more supportive of you as you need help throughout it. Other questions?
What's your dream? What would be the dream if you left Chef?
I was actually just talking with someone about that last night. So I do, it would be a job where I could combine both my technical knowledge and some sort of public service. I've worked a lot of political campaigns, and I love working them. I surprise people because I don't drink alcohol, and I work in both technology and I've worked in politics. It is possible, but being able to make societal change to that level is fantastic. I worked on the Referendum 74 campaign, which was the gay marriage campaign in 2012. That directly resulted in me being able to marry my wife 6 months later. So I love that aspect of politics, also partly, I don't think of much politics as in the dirty word, but that aspect of public service. So being able to combine that with my technological know-how would be an absolute dream job. I think that humanity will be saved by those who can combine technology. It's always going to be a part of our lives now with a deep understanding of human nature. And I think that's honestly what the industry needs the absolute most right now. So figuring out how to quantify that and get someone to fund it is a challenge, but it's what I've been working through a bit right now. But I would say that is my dream. All right, well, we have about 13 minutes left, so I'm going to hang out here. If you want to talk to me one-on-one, I forgot to bring my business cards, but that's my Twitter. That's honestly often the best way to contact me because it goes to all my devices. So feel free to reach out to me there. Sometime earlier in the next year, I'd like to do some work with Code Fellows, introducing them to the Chef open source projects, figuring out what are good first-time things, but that's going to have to wait till after the holidays. So enjoy your holidays. I'll be hanging out here. Thanks so much for coming.
field used to be related to
Yep.
LexisNexis, so.
I worked in applied discovery, so
Yeah.
I went through corporate dirty laundry 8 hours a day. And turned it into PDFs.